everyone, my name is Putri Maharani. I'm from UDAYANA University from Faculty of Mechanical Engineering. This video made to fulfill my theoretical practical assessment with the lecture of Professor Dr. Tjokorda Tirta Nindhia as EMT. And in today's video, I'll be talking about manufacturing properties of a material. This book using Manufacturing and Engineering and Technology, 6th edition by Sir Kalpatian and Stephen. Tension test. The tension test is carried out by the pulling a specimen to the tested using a machine called a universal tension machine or UT. Tension test. The tension test is carried out by the pulling of a specimen to the tested using a machine called a universal tension machine or UTM. This test is carried out to see the mechanical properties of the material being tested, such as strength, ductility, toughness, elastic modulus, and plastic modulus of the specimen. Here is the initial specimen that will be tested. This area is the original gate length or L0. After the specimen is tested, this area will be a fracture. In the pulling process, before the fracture occurs, there is something called a necking condition. In this condition, the material will be experience a change in shape when very high stress is applied. The shape will be like a neck. This is a necking. And after necking, specimen will be fractured. This is a tensile stress curve, where the x-axis is strain and y-axis is stress. From this curve, we can determine elastic deformation, plastic deformation, yield point, maximum tension strength, necking, and fracture. Here there's an offset, which is the initial point of stress in the material. If the specimen is subjected to stress and the curve rises upwards to the yield stress point, where this point will intersect with the elastic point. At this point is the limit of a specimen experience elastic deformation. What is elastic deformation? Elastic deformation is when the object that can change due to stretching, but once released, they return to their original shape. If the material is given virtual load, then the curve will rise to UTS point or ultimate tensile strength. At this point is the highest point on the material to receive the load. At this point too, plastic deformation will also occur. What is plastic deformation? The plastic deformation is the permanent alteration of shape, form, or texture of a material due to the action of stress. At this point, necking will also occur if the load continue, the specimen will be fractured. This is a formula, and this formula for stress is force of load divided by the area, and formula formula for strain is L minus L0 divided by L0, and formula for modulus of elasticity is stress divided by strain. This is the extent of plastic deformation experienced by the material before fracture. Common measure of ductility is elongation. First, elongation. The formula is LF minus L0 by times LF minus L0 divided by L0 times 100, and reduction of area, the formula is A0 minus AF divided by A0 times 100. Through stress and through strain. Through stress, the ratio of the load P to the actual cross-section area. This formula, we have the same formula for through stress, but for through strain, we have different formula. Construction of stress-strain curve. Figure A. Load elongation curve in tension testing of a stainless steel specimen. In Figure B, engineering strain curve drawn from the data in Figure A. In Figure C, through strain curve drawn from the data in Figure B. This curve has a positive slope, indicating that the material is becoming stronger as it is strained. In Figure D, through strain curve wrote on load paper and based on the corrected curve in Figure C. The correction is due to the triaxial state of stress that exists in the naked region of the specimen. This testing can be done manually using a scalpel technique, or you can also use a hardness testing machine called a hardness tester. Indication given is first, strain, second, resistant to scratching, and third, resistant to wear. Usually divided as resistant to permanent indentation. As method in hardness test have four. First, the Brinell test. The second is Rockwell test. The third is Vickers test, and fourth is Knob test. Hardness method. We have Vickers hardness tester, Rockwell hardness tester, durometer, and lip tester. Brinell test. Brinell test involves placing a 10 mm diameter steel or tungsten carbide ball against a surface with ferrite load of 500 kg, 1,500 kg, or 3,000 kg. The Brinell hardness number is HP, is divided as the ratio of the load P to the surface area of the indentation. Second is Rockwell test. Rockwell test measure the depth of the penetration, not the diameter of the indentation. The indentation is pressed against the surface, first with a small load, and then with a large load. The difference in penetration depth is a measure of the hardness of the material. Third is Vickers test. This test using a pyramid-shaped diamond indenter and load ranging from 1 kg to 120 kg. The Vickers hardness number is indicated by HP. The results obtained are usually less than 0.5 mm on the diagonal. Fourth, Knob test. Knob test using a diamond indenter in the elongated pyramid shape. The updated load generally range from 25 kg to 5 kg. Knop hardness figures are indicated by HK, especially suitable for a small or very thin specimen and for brittle materials such as carbides, ceramic, and glass. Hardness testing procedures. First, the zone of the deformation under the indentar must be allowed to develop freely. Second, location of the indentar should at least be 2 diameters of the indentar from the edge of the specimen. The third, the thickness of the specimen should be at least 10 times the depth of the penetration of the indentar. Fourth, the indentation should be sufficiently large to give a representative hardness value for the book material. Impact. Testing material by means of instantaneous loading on the test material aims to determine the material ability to absorb impact energy until the material experiences plastic deformation or fracture. There are two kinds of way. First, the Charpitas, and the second is isotest. The test specimen is supported at one end. Then the specimen is placed on support with the position and direction of the load in the same direction as the notch. And the Charpitas, the test specimen is supported by both ends. Then the specimen is placed on support in horizontal position, and the direction of loading is opposite to the direction of the notes. This opposite, and this the same direction. Metallography. Test to observe the structure of the material which contain information on grain, shape, grain size, sizes of the material. Preparing microscopic metallographic specimen. First, sectioning, second, mounting, third, bending, fourth, polishing, and fifth, etching. Sectioning. The process of sectioning is the process of cutting a specimen to be tested into the desired size. The second is mounting. Because the size of the test material is small, it is necessary to add resin so that the hardened resin becomes a grip during the testing. Third is grinding. This process aims to smooth the specimen being tested so that there are no scratches. And fourth is polishing. This process aims to make observation easier when using a microscope. And please, etching, chemical milling, or industrial etching. Structure the material grains on the surface according to their crystal orientation.